Episode 131 of CppCast with guest Nicole Mazzuca, recorded December 14th, 2017. This episode of CppCast is sponsored by Undo. Debugging C++ is hard, which is why Undo's technology is proven to reduce debugging time by up to 2/3. Memory corruptions, resource leaks, race conditions, and logic errors can now be fixed quickly and easily. So visit undo.io to find out how its next-generation debugging technology can help you find and fix your bugs in minutes, not weeks. And by Audible. Get a free audiobook download and a 30-day free trial at audibletrial.com/cppcast. Over 180,000 titles to choose from for your iPhone, Android, Kindle, or MP3 player. In this episode, we talk about some Visual Studio updates to help manage warnings. Then we talk to Nicole Mazzuca. Nicole talks to us about the C++ object model. Welcome to episode 131 of CppCast, the only podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
I'm doing okay, Rob. Yeah, through the magic of radio here, I guess. This is being recorded one day after the last episode.
Indeed, we're doing time travel again.
So I got a new tooth.
Nice.
Because we did mention that. And I think I'll, maybe be a little bit more alert today, hopefully.
That's good.
But we're doing time traveling here, not time travel debugging, mind you.
Right.
Just time traveling of the episode because I'm heading off to Poland to do some training there on Saturday.
Awesome. So, can you tell us what company you're going to? Like who you're going to be seeing in Poland?
It's I don't know. I didn't discuss with them if they want me advertising that or not. But it's a consultancy that's in Wrocław, and it looks like it'll be a beautiful time of the year. They're expecting some snow, and they've got a wonderful Christmas market downtown. I'm hoping to see
nice.
that. Yes,
very nice. That should be fun. I also am wishing we could do some real time traveling right now because I'm very excited for the Star Wars movie coming out this Friday.
Isn't that? Oh, I thought that was tonight for some reason.
I think, yeah.
Oh, the midnight showing.
Midnight showings. Yeah, I might try to find one of those.
Well, yeah, you've got kids. I'm sure they would love to go.
Yeah, I'll have to do that. Well, at the top of every episode, I'd like to read a piece of feedback. This week, we got an email from Nikolai Zapaklov. And he writes in, "Hello, Rob and Jason. Your show is really useful for new developers to introduce in the context of developing software and in C++ especially. Thank you. Could you touch the topic about wrong using design patterns? I heard a lot of developers very often abuse using design patterns. Maybe someone can share his experience about restrictions in using design patterns and when they stop working." So yeah, we haven't really done any episodes on design patterns.
Are you a design patterns guy?
I wouldn't say I'm a design patterns guy. No, you?
I feel like I know almost nothing about them.
Yeah.
I mean... And I've seen discussions where people say, well, why doesn't the standard library have templates for the various design patterns that are the most popular? And the responses seem to be something along the lines of, the design pattern should be a guideline, not something you try to shoehorn all of your designs into, basically.
Right.
But I don't know. It's been on my to-do list for literally over a decade to make sure I understand.
Familiarize yourself better? Yeah.
Yes. I should probably get to that to-do item at some point.
Yeah, I could definitely see doing an episode about it too. Just could we get someone on who is very familiar with multiple design patterns and can speak to, this is good for that, this is not. Or,
do you know who the Gang of Four is?
I'm familiar with the book, yeah.
Yeah. Well, maybe we should try to get one of those guys on here.
Yeah, that'd be good.
That'd be crazy.
Yeah. Well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes. Joining us today is Nicole Mazzuca. Nicole is someone who's thought a bit too much about object models and error handling. She started in C, moved to Rust, and then fell into C++ a year ago. She also loves coffee and latte art. Nicole, welcome to the show.
Hello.
What do you think of design patterns, Nicole?
I have not ever really thought about them, to be quite honest.
I thought with that intro of object models, but that's object modeling versus memory object models, right?
Right, yeah. It's more like objects have value semantics as opposed to objects are patterns, I guess.
Right.
Like, the only thing I can even think of that I do that's anything close to a pattern is, like, Sphinx or something.
Yeah, that's really not one of the one of the design patterns, I don't think.
Hey, it's very important to design your classes to be Sphinx friendly.
Yes. So, do you want to talk about this love of coffee art at all?
I mean, it's just, I like making latte art. It's a fun thing to do on coffee, and people get happy when I'm a barista in my everyday life.
Right, that's an important note, I think, here,
Yeah,
yes.
Right.
And I don't know, people tend to enjoy it when I make latte art, because latte art's awesome.
Some of the pictures I've seen on the internet are like nuts. Like, what kind of things do you do?
I am not that good.
You're not like make a Darth Vader?
No, I cannot make a Darth Vader. I've not been practicing for 10 or 20 years. I mostly do like hearts and like leaves and stuff like that, just basic stuff.
Oh, that's cool.
Yeah. Okay, well, Nicole, we got a couple news articles to discuss. Feel free to comment on any of these, and then we'll start talking more about your love of the object model, okay? Okay. So first, the Meson build system release 0.44.0 is out. Jason, anything really big to share with this one?
I don't know if there's anything in particular stands out, but I think it was just important to mention it because we've talked about Meson on here before.
Sure. We haven't done a dedicated episode yet, though, I don't believe, right?
I will have to look.
I don't think we have. No, I don't think we have. We've talked about CMake a whole lot more than we talked about some of the other build systems like Meson.
We did talk about Meson. There we go.
You're right. You're right. Episode 38. It was a long time ago.
with the author of Meson, yes, which is why I was thinking we should have this up here. But anyhow.
Yeah. Okay.
Are you involved in build systems at all, Nicole?
I've thought a lot about their design. And me and Izzy Muerte were going to do some work on a build system, and we've kind of started a little bit.
A module-friendly build system, perhaps?
Yeah, definitely. That's something that's really important to me. I don't think it's going to be in the initial release, but definitely important to look at modules.
Right.
Okay.
Yeah.
Next up, we got a C++ Now 2018 call for submissions.
Yes.
And this one, what is the dates on these, Jason?
Oh, that's terrible. That link that I had in there didn't say the exact date. It's March, I believe.
It says submissions due are January 24th.
Oh, January 24th. Okay.
And then decisions get sent out February 26th. Program will go online March 18th.
So I have made my submission.
You're already in? Okay.
Yes. This year I am attempting to give one talk.
Well, that's good. Just one talk. Because didn't you
just
send
one
in
talk, yes,
3 last year?
Yes. It is my goal to go to this conference and give one talk. We'll see what happens. The risk is you make one submission and it doesn't get accepted, right? Then you have to decide what you're doing.
I think it's a lot better than sending in 3 submissions, though, and getting 2 accepted and not being able to handle it.
Well,
or getting all 3 accepted.
Hey, I think I've always.
Oh, I know.
Will you? Are you planning to submit anything? Either one of you?
I don't have any plans right now to submit anything. How about you, Nicole?
I don't either. I don't really have anything that I want to say right now. I've mostly been using OCaml recently and not C++, so I don't have a lot of opinions about C++ right now.
Okay.
Okay. Next, we got 2 articles from the Visual C++ blog. This first one is Code Optimizer Improvements in Visual Studio 2017 versions 15.5 and 15.3. So it looks like they made a ton of improvements between 2017 and the 2015 update 3.
Yes.
Yeah.
And I think more important than the fact that Visual Studio now has these optimization features is, as a C++ developer, reading this article to understand what kinds of optimizations the compiler writers are thinking about.
Right.
And there's some technical stuff in here, lots of assembly examples, how conditional moves can help the code, for example, and then things like CSE, common sub-expression elimination and stuff. It's an SSA is mentioned here, single assignment, static single assignment form, which is also important to understanding how optimizers work. I feel like I have a passing familiarity of these things, but for anyone who's interested, they should read this.
Yeah, it's definitely worth scrolling through the article and seeing kind of how the optimizer is working with some of these improvements.
Yeah.
Yeah.
The loop unrolling is really interesting, in my opinion. How they do loop unrolling and then are able to optimize based on the loop unrolling. It feels very similar to the stuff that you can do if you inline.
Yeah.
So it's just I don't know. I like that. It's cool.
Yeah, that's something I've been thinking about a fair bit lately and discussing with others in loop unrolling. At what point does the cost of making your instruction cache bigger, blowing out your instruction cache, if you will, by unrolling everything, outweigh the benefit of doing the unrolling, since modern CPUs are really good at jumping and keeping hot code and path in the cache. But this kind of example like they have, where you've got a known size and they know that they can exactly unroll it to 4 things, I feel like that has to be a clear win. And then the optimizations that they can perform after that, like you were saying, is pretty cool.
I feel like for real programs, there are a lot of little loops like this. But it would be, I don't know. I'm just thinking about loops with 128 or something like that. And at that point, you just kind of you're probably unrolling it 8 times and then looping, as opposed to unrolling it, 128 times, which that's an insane number and will not keep you in iCache.
Right. The partial unrolling that some of them will do. And I've also noticed with this kind of loop, if there's a known size or something with partial or full unrolling, and these were you're working. The unrolling gives the vectorizer the chance to work and potentially use SSE instructions also.
Yeah, exactly.
Okay, and then the other article we have from the Visual C++ blog is the broken warnings theory. And the main thing that they're announcing here is these new external compiler switch groups, which will allow you to basically disable or change the warning level for external headers. And this is something that I think will be really useful for getting a build with clean compiling without warnings, or with all your warnings turned on, not having to worry about all these external headers.
Did you notice in the statistics at the top of this article, they say 27 respondents to their survey, 27%, of the respondents to their survey compile Visual C++ applications with -w all.
Yeah.
And I find this fascinating.
Mm-hmm.
I mean, that's what I do. I do -w all, and then I just turn off specific warnings.
In Visual Studio?
In Visual Studio and in Clang, I use W everything and turn off specific warnings.
I have found, so there's a philosophical difference here, right? Because Clang and GCC exclude themselves from warning messages. The standard library excludes itself from warnings. It's treated as a system header by default. In Visual Studio, it does not. The standard library does not exclude itself from warnings by default. So when you turn on W-all, if you include even the simplest header in Visual Studio, you get a bunch of warnings and you have to selectively disable some of them. But I think this is actually better because Visual Studio is clean up to W4 and Clang is not. And GCC is not. The standard library isn't because they exclude themselves from this. Anyhow, I like the way the Visual Studio team does it, but I also find it kind of handy to have these new tools that Rob was pointing out.
Yeah.
Yeah.
Go ahead.
So one thing that I'm noticing is like one modules kind of makes this obsolete, and that makes me happy.
Mm.
What was the other thing? I was going to say something and I can't remember. Oh, it was really interesting, like talking about this article on the Slack, because like how different developers have relationships with warnings. Like when I'm writing code, I will correct all of the errors and warnings before like doing anything. But I was talking to this person who like, as they're refactoring, they want to debug without fixing all the warnings. And it was just a like really interesting like difference in
developer
process.
behavior. Yeah.
Yeah.
Yeah, I feel like fixing the warnings first is probably going to make my debugging task easier because
Right.
there's
Yeah.
probably a good reason those warnings are there.
I mean, on the other hand, you have like unused variable warnings and stuff like that, which is what they were referring to. It's like it's an annoying thing.
Yeah, unused variables are significantly less likely to be
An
a
actual
warning that's going to
problem.
cause a bug. Yeah.
Yeah. Okay, well, Nicole, at CppCon this year, you gave a talk on the C++ object model. Can you tell us a little bit about the talk and how it went?
Yeah. So it was my first talk ever, and it was very nerve-wracking, and it was a ton of fun. I feel like I could have prepared better, but otherwise it was like a good talk. And I just kind of, it was mostly about like where in the C++ standard we needed to like fix some stuff or like work on some wording. Like the wording around const and reference member variables inside of classes is a bit weird. It's like if you have a const or reference member, you basically can never like put a different thing in that space.
Right.
So like if you have a vector, for example, and you have a type in the vector with a const or reference member, and you push back and then you pop back and then you push back again, that's like undefined behavior. Like the standard libraries are committing undefined behavior by doing that because there's no way to actually do this correctly, basically.
Let's like dig into that. Like,
Yeah.
how so? What is this pushback, pop, pushback, pop, pushback, whatever? How does that invoke the undefined behavior?
So basically, what you're doing is you're constructing an object into storage, right? Like the storage does not mean anything, but you're putting an object. It's uninitialized. It's uninitialized storage. You're putting an object in there.
Right.
So the pointer that the vector uses to like point to the array now points to an object.
Okay.
And you pop back, and that deletes the thing, and then you push back again, and because it had a const or reference member, the new object, the pointer does not point to the new object. It just points to memory where the new object is located.
Okay.
And this is so that, obviously, implementations can optimize out, like, if you have a const or reference member, you can check it once and then you never have to check it again, basically.
Right.
But because of this issue with vector and, like, issues with, like, placement new and stuff, no implementation actually does this yet. They do it for vtables,
Right.
which is less of a big deal because, like, if you're changing your vtable, you deserve to get bitten. But that's what standard launder was introduced to do. Unfortunately, you basically have to use std launder at every single access point, and like it's a huge pain, and it also doesn't work for some reason. I can't remember exactly why. And it also only works for actual pointer types, as opposed to like custom pointer types as well.
Okay. So there is an object at a particular memory location. It has a const value, a const member. The compiler is allowed to optimize around that.
Yep.
And we've just replaced that object with a new object.
Yep.
And now the next time we go to access that const member, we are potentially invoking undefined behavior because the compiler was allowed to optimize around the const.
Basically, yeah. And there's like no way to get around it.
Except for laundering the pointers.
Except for laundering the pointers, but then you have to use the return result of launder, and again, it doesn't work with custom pointers and stuff.
Right. And at that point, you have significantly crippled the optimizer, probably, if you're laundering every single access to every single object in a vector, for example.
I mean, I don't think it'd be, like, except for vtable optimization, it shouldn't be a major thing.
Okay.
And for vector, you don't really have issues with vtables because you can't really have multiple dynamic type objects.
No, you have vtable-like things if you have a vector of variance, but they are not exactly the same thing, yeah.
Yeah. So it's like, for that specific use case, it's not like a big deal because the compilers don't do the optimization anyways because it would break code. And it would break standard library code that's supposed to work. But, like, yeah, so it's kind of a CF.
I'm kind of, I'm a little, like, since I don't know the details of where exactly the compiler's allowed to optimize, like, I've tried to familiarize myself with them, but some of these things are, like, you have to know, like, 6 different parts of the standard, right?
Yeah.
Once you have called the destructor on an object or reused its memory location, then the lifetime of the first object has officially ended. I know that rule. So at what point, since you've ended the lifetime of the first thing, and then you've replaced that, like, that it seems like, it seems like, what is the compiler supposed to do there exactly?
So basically, you end the lifetime of the old object, and even so. This is some really arcane stuff.
Yeah.
So
our listeners like it when we get more technical.
That's good. So let's say you have a pointer that points to an object. Right?
Yes.
Now you don't delete it. You placement destroy. What is that like?
You can just manually call the destructor. Yeah, you don't
manually call the destructor. I don't actually know what that's called, but I'm going to call it manually calling the destructor.
I think that's the
manually call the destructor on this object that's at this certain memory address.
Yeah.
The pointer now points to nothing, right?
Right.
Or it
points to an invalid object, I guess, technically at this point, right?
Yeah, basically. If you then placement a new object into that storage,
yes,
the pointer points to the new object.
Yes.
If and only if the new object is the same type as the old object.
Yes.
And the new object, and the type of the objects that are the same, because otherwise it wouldn't point to the new object, because, TBA and stuff. And there are no const or reference members.
Oh.
That kind of makes sense?
And there are no const or reference members.
Yeah. So if
that's handy.
Const or reference member, then the old pointer that pointed to the old object does not continue to point to the new object.
So there is actual specific wording around that.
Yes.
Okay.
So
wish I did not know that now.
If the vtable changes, that it's the same wording, right? So I don't believe that it's actually like I think you can access non-const and non-reference members, but it's accessing the const or reference member that the sub-object inside the object that's const or a reference, even though it's not actually an object if it's a reference.
Right.
It like doesn't point to the new one. It points to invalid because you destroyed it's crazy, and it's just written so that your optimizer can trust that constant reference members never change, but the issue is they do.
That is that's crazy. I was not aware of that.
There's a lot of crazy stuff in the C++ standard. Const PR values, they're great.
Well, so
Go ahead,
Rob.
Go ahead,
Sorry.
Jason. No.
Well, I was going to say I interrupted you in the middle of what you were saying to dig into this. I was just wondering where you were going to go next, but if Rob has a question along these lines first.
I was just going to say to roll back a bit, I kind of want to know where you got so interested in the C++ object model in the first place. I mean, we've had listeners who are really interested in compilers and they go and build their own compiler. I just kind of want to know what the history was there.
So the history basically starts with Rust. I was a Rust programmer for a really long time. I'm not really anymore, but like I was for a long time. And one of the things that I started kind of getting into like really unsafe code in Rust.
Like that tweet you recently sent out?
Yeah. No one liked the original tweet where I printed my name using using the fact that Linux has read-only memory as executable. But everyone liked my tweet that it was like replying to somebody. Oh, yeah. I think wasn't it you?
Yes.
It did that. Yeah. Okay. So everyone liked my tweet about technically everything is executing memory, and I thought that was kind of it made me sad because I'm really proud of that snippet.
I guess, and unfortunately, we've derailed again. But for the sake of our listeners, you wrote a statement of Rust, and see if I can get this right, and you can correct me if I'm wrong, where you put some effectively hand-compiled code in, and then jumped into this code and executed it, which is the kind of thing that you would say Rust shouldn't be allowed to do because Rust is very safety-conscious.
But there's an unsafe keyword, so you can do whatever the heck you want, including execute undefined behavior.
Okay.
That's kind of like, so the thing about Rust is the idea is that you can't have undefined behavior if you don't have the unsafe keyword, and the unsafe keyword allows you to do undefined behavior. That is not true because LLVM is bad, but no, LLVM is awesome, but it does do some stuff that like you cannot work around. Like, for example, a int to float cast and float to int cast are undefined behavior if they're outside the bounds, and you cannot do anything about it.
In Rust.
But in LLVM semantics, so you can't, there's no like, just do whatever the hardware does.
Right.
Like, the optimizer will always assume that an int to float or float to int cast is undefined behavior if it goes out of bounds, which means that you can like do whatever the heck you want in Rust if you have an out of bounds float to int or int to float cast.
Okay.
And then also like infinite loops, they're optimizable in C++. They're not optimizable in C and Rust. Or like infinite loops without side effects.
Right.
But LLVM just assumes they're optimizable, which is bad because it breaks C and Rust.
Oh, interesting.
I think they're fixing that with like an intrinsic. But anyways, I got into unsafe code in Rust. And one of the things that's like a big part of unsafe code is like this function in the standard library called Transmute, which is basically C++, you'd call it bitcast. Like it's take the bits of one object, take the bits of one object, memcopy them into an object of a different type, basically. Mm-hmm. And Rust like checks that they're the same size, and it's incredibly unsafe, and people use it for pointer casts, and it's really, really, really not good. It's a big thing, anyways. But like as part of the transmute, you have to be interested in like object models and how all that works together. So I got interested in the Rust object model, and then as I kind of fell into C++, I got really interested in references, because references are really cool. Like, I feel like references are probably C++, like one of C++'s top features.
Interesting.
They're unfortunately not super ergonomic, and there are some mistakes that were made in the design of references, in my opinion. Like, for example, forwarding references, I believe I would argue they're a design mistake. But basically it's like they're a really cool feature because they're C++ is the only language that I know of that allows you to have, like, a value which is an object. Okay. That kind of makes sense.
The reference itself, you're saying.
The reference itself is a value which is an object. Like, you are able to pass objects around as if they were just normal values.
Mm-hmm.
And, like, you can pass values around as well. Like, as opposed to, like, something like OCaml, where everything is a reference. In C++, you have both reference and value semantics, which is really, really cool. And I'm not being super awesome, like, talking about, well, not talking about this super well, but, like, it's really cool, is the point. And it fascinated me. And then I got into the object model of C++ through that, kind of. And, like, reading the standard a lot, because the standard's really fun to read.
So I believe you are officially the only guest we've ever had who would actually say the standard is really fun to read.
And we've had people on who work on the standard.
Yes.
Yeah.
It's like, it's legal language. It's really enjoyable to, like, suss out the actual intended meaning, and, like, I don't know. It's fun. It's fun.
In my classes, I try to do a little bit of, like, learning how to read the standard for when you need it. Not like reading the standard for fun and pleasure or something. It's not, I don't think of it as bedtime reading, you know.
I mean, clearly you've never read the, Michael Case did the, beat poetry C++. Like, that is actually in the C++ standard.
Yeah.
And I love it so much.
That was the secret lightning talk from Meeting C++ 2016, I think.
I think so, yeah. I've like literally shown that to people who are not programmers and been like, look, C++ programmers are awesome. And, like, you have, like, fun stuff like the .zombie namespace in the standard, which is for, like, things that are deprecated, I think. The standard is a barrel of laughs. Let's just say that.
All right, everyone, you've heard it from Nicole. You should have fun reading the standard after this episode.
Yeah. And also reading old standards is really fun, because you're like, what the heck were they thinking? Like, there is a clause in the C++ 03 standard that basically says, if you bind a reference to a temporary, or like an object of the same type, the compiler is allowed to emit infinite copies.
Allowed to emit infinite copies.
Yeah, there's an implementer's note that says, note, you may want to stop, because otherwise it would be useless. Or it was like, no, you might want to stop at some point, because otherwise you'll have infinite recursion.
This seems like it must have been around the wording that I think most people aren't maybe necessarily familiar with, and I honestly need to spend a little bit more time with, but how you can extend the lifetime of an object returned from a function by assigning it to a const reference.
It's not actually related to that.
It's not related to that, okay.
You know, it's like so basically there's a thing which says there's two things you can do with a temporary to bind it to a const reference.
Right.
You can copy it into a new temporary of the reference type.
Uh-huh.
Or you can bind the temporary object to the reference.
Okay.
But the issue is, it doesn't say, like, you can only copy once. It just has those two things next to each other.
Okay.
So it says, like, you put the object you put the temporary object into a new object and bind the const reference to it.
Right.
And in order to bind a const reference, you do that, or you just bind the reference to the temporary.
Okay.
And it doesn't say, like, you can only do this copy once. It has an implementer's note. You might want to stop at some point because it will infinite recursion otherwise.
All right.
There's a lot of really silly wording.
I wanted to interrupt this discussion for just a moment to bring you a word from our sponsors. You have an extensive test suite, right? You're using TDD, continuous integration, and other best practices. But do all of your tests pass all the time? Getting to the bottom of intermittent and obscure test failures is crucial if you want to get the full value from these practices. And Undo's live recorder technology allows you to easily fix the bugs that don't otherwise get fixed. capture recordings of failing tests in your test suites, and debug them offline so that you can collaborate with your development team and customers. Get your software out of development and into production much more quickly, and be confident that it is of higher quality. Visit undo.io to see how they can help you find out exactly what your software really did as opposed to what you expected it to do, and fix your bugs in minutes, not weeks. So as someone who studies the object model and reads the standard, what do you think is something the average C++ developer should know about the C++ object model that they probably don't already?
Honestly, there's not too much that you need to worry about. It mostly just does the right thing. Like, except for some major, some issues with constant reference members. And this isn't really related to the object model, but const PR values as well. Like, those three things are really the only major things that you kind of need to worry about. So constant reference members, basically, the lesson to take home is don't ever use them. Just use pointer and mutable, or not, non-const members. Or like std reference wrapper or something.
Well, const members are very difficult to work with effectively.
Right. So, just don't worry about that part of the standard. Just don't use const or reference members. Is basically the idea. And then on const PR values, basically just never return a const object from a function, because the C++ standard does some weird stuff with it.
Yeah, it's generally considered best practice that never does what you want it to actually accomplish, so stop doing it.
Right. Oh, and always put ampersand on your operator equals. Ref qualify your operator equals, so you can do as the ints do, and not take L values.
So
or operator ref. Yeah, operator ref.
You say always ref qualify your operator equals.
Operator equals.
Specifically the copy operator or the move operator or move assignment?
Like anything that is an operator equals. Just because then then you can't say if your class is foo open paren close paren equals other foo.
Right. So you can't assign to a temporary effectively.
Yeah, basically.
Okay, so if I were to say I want the default implementation that the compiler is going to provide for me for my assignment operator, would you recommend that you do the ref qualified equals default?
Yeah.
Does that prevent the compiler from creating the R value ref qualified one, or do I need to explicitly delete that one?
I haven't actually checked.
That's an interesting question.
I'm going to check on the compiler explorer because that is curious to me.
I'm guessing it would prevent it from being created, or it will.
I do too.
Because it can't create the non-R value reference qualified one, because you can't have both reference qualified and non-reference qualified versions that overload each other. And by default, it's not going to make the R value qualified one. So
yeah.
So we did some investigation that Rob has edited out, and it's not entirely clear what the compiler is doing at this point, and it's going to take some more investigation, and hopefully Nicole will write up an article on this or something that we can link to later.
Definitely do that.
Yeah.
I just volunteered you for that.
Okay, good. But yeah, basically, as long as you avoid returning const objects from functions, like const foo, bar, open paren, close paren, as long as you avoid constant reference members, and as long as you... No, those are the two big things. That the C++ standard will do what you expect it to. There are some, C rules that you cannot follow, like the whole union thing. You can bitcast it from unions in C, but you can't in C++. But other than some stuff like that, it's mostly just, it does what you expect it to. Honestly, the committee has done a really great job at the C++ 11 and up models. They are absolutely fantastic as far as object models and all that goes, in my humble opinion.
Yeah, we've had other guests say that the C++ 11 object model literally changed their business because it made more things possible. Mm-hmm. Memory model and object model, yeah.
Yeah, the memory model's great. The reference model's great. The object, C++ 11 turned a pretty crappy language in C++ 03 into a friggin' fantastic language. It's like the standards committee does not get enough recognition for how much work they've done.
So as someone who used to be more involved with the Rust community, what would you say that C++ could maybe learn from Rust?
More static analysis is, I think, always a good thing. I feel like something like Sal, Microsoft Sal, which are those really weird C things that you write in, like, out param and stuff in the Microsoft.
I don't think either one of us is talking. Yeah, we're not sure what you're talking about.
So in Windows code, basically, there's a lot of, like, attributes.
Okay.
That like, you, like, write around stuff. Like, for example, this size t parameter is the length of this other pointer parameter.
Okay.
So you can do, like, good annotation, or not annotation, static analysis around that.
Right.
And you're losing a lot less information as you do function calls.
And you can specify in parameter, out parameter, in out parameter, or whatever.
Exactly.
Okay.
And I think that it would be good to, like, it would be interesting to add, like, lifetime annotations in that kind of way. Because I think lifetimes are a really big deal and they're really cool. The other things that I think C++ could learn from Rust is more safety by default. Like, one of the things that C++ does really well is fast by default. But for most things, you don't actually need it to be that fast. Like, I think that ftrap v, like, if you overflow an integer, you trap, as opposed to undefined behavior, would be, like, a really good default to have for compilers.
Interesting.
And in general, stuff like operator, open bracket, close bracket for vector, it should trap if you like, do a buffer overflow, because that's like a safety issue at that point, and it's like it will screw up stuff. And I think that C++ people are a little bit too obsessed with speed over safety. And specifically, making the easiest path the unsafe, speedy one.
Right.
Like, it would be totally fine to have, like, operator, open bracket, close bracket on vector, check for overflow and trap if it overflowed, and then just have, like, an unsafe get or unchecked get or something.
As opposed to the opposite of what we have right now, where the index operator is unsafe, but then we have .hat if you want it to do a check.
Yeah, and also there's a lot of, like, exception throwing in the C++ like, .at will throw an exception if you do it, but, like...
You'd prefer just a crash, CPU trap.
I would prefer just a crash, because you're saying, this is a bug, but it's not going to fuck up the rest of your code. Or it's not going to screw up your... Sorry for swearing. Okay. It's not going to screw up your security or whatever. It's just going to crash.
Right.
Like, you have gotten to a point where your business logic is incorrect, and we are going to crash instead of letting you continue with that.
Interesting. So how do you feel about the, or if you spend any time at all looking at, like, the checked integer library kinds of things that do some of what you're talking about, but you have to, well, I guess you already said that you would prefer that the easy path was the safer path as opposed to the other way around, but...
And, like, unsigned overflow is, like, why is that? Why can't I have trapping unsigned overflow and, like, undefined behavior unsigned overflow? That I really dislike that about... Like, the fact that unsigned is overflowable is weird to me.
That is an old history where that was actually the desired behavior in some 16-bit things and 8-bit things back in the day.
Yeah, I know, and it also frustrates me as, like, a modern developer.
Right.
Because, like, I can't say, you know, unsigned is trapping on overflow, because some other library might depend on it overflowing, and it's just a big crock of annoyance.
Right.
But yeah, I feel like more checks are a big deal. Also, Rust allows you to do really, really unsafe things behind the unsafe keyword. Like, you could just get the pointer and the size out of a vector, or pointer size capacity out of a vector, and then recreate them.
Okay.
And I've wanted that a lot in C++, where I'm like, say, writing a span type that's owning, and I want to take the memory from a vector, or like put the memory back into a vector.
Right.
It would be useful to have like these unsafe utility methods.
Okay.
That's interesting to hear that you want some of the unsafe features of Rust brought into C++, but you want the safe features of... You also want the safe features of Rust, I guess, brought into C++.
Yeah. The C++ is kind of in the middle between Rust. So you have like safe Rust and unsafe Rust. C++ is like safer than unsafe Rust, but more unsafe than safe Rust. And I want it to kind of spread out.
Okay.
Like as safe as safe Rust and as unsafe Rust.
Interesting.
Because Rust lets you do some insane things.
Okay.
So you're a barista.
Yeah.
You read the C++ standard for fun.
Yeah.
And you've started with Rust to C++. You said you're working on OCaml largely now.
Yeah. I'm building a compiler for a language that I'm designing, and I got fed up with Rust, so I'm now writing it in this re-syntaxing of OCaml called ReasonML, done by Facebook, which I really like.
I didn't know that Facebook had been involved in the OCaml world at all.
Yeah, actually like 50% of Facebook Messenger is written in this re-syntaxing of OCaml called ReasonML.
Huh.
And ReasonML is just basically OCaml, but with kind of more JavaScript-y syntax.
Okay.
Which is much nicer to my eyes, because I really dislike... There are a lot of issues with OCaml syntax that I'm not going to go into, but ReasonML kind of fixes most of them, if not all of them, and JavaScript syntax is actually kind of pretty.
Kind of.
At least I like braces and semicolons. What can I say?
So what's next, though? I mean, are you pursuing a language, writing your own language is a hard thing. And I'm just trying to remember, I think it was when we had Strustrip on that he has said something along the lines of, don't ever create your own language because either it'll be successful and you'll be stuck doing it for the rest of your life, or it'll fail. Something along those lines.
I mean, so if it fails, I got a lot of knowledge.
Right.
And I can yell at the C++ community to add stuff. And if it doesn't fail, then yay, I can write stuff in a language that I like, that has like linear types and like is similar to ML, or like is like ML but with C++ level performance. That's great to me, and like has destructors and all that, because every language should have destructors. Destructors are amazing.
Yeah, I thought it was very interesting when you said that references are the main feature of C++, when generally speaking the answer everyone gives is destructors.
So the main features of C++, in my opinion, are destructors, references, from a programming language design perspective, not from like a using C++ design.
Right.
References are really cool, and I don't know any other language that really does them like C++ does. And I think that's sad. It has really cool destructors, obviously, and the idea of value semantics is really cool, if not executed super well.
Okay.
Copy by default is a really bad default. And it's unfortunate that that's the way that C++ went. It makes sense that that's the way that C++ went because of the early days. But in my opinion, it would have been better to do kind of like an affine type system similar to Rust, where like it's moved by default and you just like...
Yeah, making...
Like, if you have
yeah, go ahead.
Yeah. And like you don't call the destructor on a move from object.
Okay, right.
Like the compiler does that as opposed to the programmer.
Right. So I'm just curious what's next, though. I mean, you're working on this programming language. Do you have any plans to go into programming full time, or?
Yeah. Well, so I finished my associate's degree, and I'm going to go do a master's a bachelor's at Western Washington University.
That's great.
In the north of Washington.
Computer science?
Math.
Math. Okay.
Yeah, because math is computer science. If you're not going to like a very few specific schools, is not, in my experience, a very well taught field. It's like it's very inconsistent.
Okay.
The quality of teaching.
Right. I mean, it's been a while since I've been in university.
Yeah.
17 years since I graduated. My computer science program was highly theoretical with enough math that if I had taken one extra math class, I would have gotten a minor in math. But due to other reasons, I didn't actually end up... I started down that road, didn't manage to complete it, so I did not get a minor in math. But yeah. And I know that...
As some, like, I'm super interested in, like, the theoretical stuff, and I don't want to do a lot of the programming stuff, because, like, I've done a lot of that. I've programmed for, like, 10 years. Like, it's fine.
Okay.
I don't need the practice of, like, object-oriented programming.
Right.
Okay.
Yeah.
Was there anything else you wanted to share? Like, where can people find you online? Do you have a blog, Twitter?
I have a Twitter. I do have a blog, but I haven't updated it in, like, 2 years or something.
Okay.
The last update that I have on it is, like, so there's a style guide in Rust that was terrible and, like, had a lot of issues. And the default formatting tool did that style that was really not very good. And so I wrote a competing style guide and got myself on the style team, and now, in my opinion, the Rust style is fairly good. It's better than it was. Match statements, the variant, like, switching statement, they still double indent, which annoys me. But other than that, it's really good.
Okay.
I kind of wanted to talk about Mason a little bit, actually.
Sure.
Because one of the things is, like, the issue that I have with Meson is, like, this is the best that the C++ community can come up with. It's kind of depressing. Like, I was trying to run Meson the other day, and, like, try it out, and it's incredibly unintuitive. And I feel like C++ needs to get, like, something like Cargo or, like, OCaml's JBuilder that just makes it easy and you don't have to worry about it too much. And, like, it just does the defaults well.
The problem is, C++ has so many more compilers and tool chains and everything to try to work with, right?
I mean, it does, but, like, so one of the things that I have an issue with, like, modern C++ build systems, which are not all that modern, really, is they don't enforce a directory layout.
Right.
Which means that you have to put all the directory layout information into the build file. So, like, for example, you have to, apparently in Meson, you have to say that your include directories are in include. Like, that doesn't seem like you should just have a single build layout, and, like, that's fine. And, like, you could do, like, a TOML file. And I feel like C++ needs to make that shift at some point soon. Because it's putting off new programmers to C++. Like, if somebody wants to pick up Rust, they install a compiler with Rust up. Oh, and, like, the compiler installation is also really bad. But they install a compiler with Rust up, and it installs Cargo and everything as well. And then you do Cargo new project name, or Cargo new -- bin project name, and you're done. You have a project. All you have to do is start editing Rust code. Whereas with C++, you have to do all of this setup, and, like, to build Meson, and Meson looks like one of the better options out there, if not, like, one of the best. You still have to use, like, Ninja and, like, all this confusing stuff that is, like, incredibly weird to, like, a new programmer.
No.
You know?
So in your hypothetical build system that you've thought about but haven't implemented yet, would you enforce a specific, like, file layout for the project?
Yes.
Okay.
Like, hands down. Like, you'd have a source directory and an include directory, and in your source directory you'd have, like, the module files and also the C++ files. Like, that just definitely needs to happen, in my opinion, is, like, an actually enforced directory layout. And it won't be able to, like, old projects won't be able to go over to it, unfortunately, like, easily. But it's not a big deal as long as you can interface with old build systems. Mm-hmm. Like, the thing about OCaml, the new user experience isn't great either, especially on Windows. But the build system's pretty simple. Like JBuild is really simple. It's not great, but it's pretty simple. But the thing is, like, this new build system can also interface with all of the old build systems.
Okay.
Know? And so you don't have to worry about, like, having an old build system with a new build system. You just have a package and then you can interface with that package.
Interesting.
Yeah.
And I think that C++ could do something similar.
Right.
It's definitely something we definitely need improvement in the C++ community. Yeah.
Yeah. The big issue is, like, new users.
Right.
Like, people are getting turned off C++, and it really sucks because C++ is a really good language. And it just has a terrible build story, and people don't use C++ because of it.
Right.
Okay. Well, it's been great having you on the show today, Nicole.
Yeah. It's been fun.
Yeah, thanks for coming.
Thanks so much for listening in as we chat about C++. I'd love to hear what you think of the podcast. Please let me know if we're discussing the stuff you're interested in. Or if you have a suggestion for a topic, I'd love to hear about that too. You can email all your thoughts to feedback@cppcast.com. I'd also appreciate if you like CppCast on Facebook and follow CppCast on Twitter. You can also follow me at Rob W. Irving and Jason at LeftKiss on Twitter. And of course, you can find all that info and the show notes on the podcast website at CppCast.com. Theme music for this episode is provided by podcastthemes.com. Website at CppCast.com. Theme music for this episode is provided by podcastthemes.com.